So blockchain, we would be simplifying blockchain today in this talk. Okay. Uh, so what is blockchain? According to Wikipedia, the blockchain is originally a blockchain that is continuously growing of records called blocks, which are linked and secured using cryptography. Each block typically contains a hash pointer as a link to the previous block, a timestamp, and transaction data. By design, blockchain are inherently resistant to modification of data. Blockchain can serve as an open, distributed ledger that can record transactions between two parties efficiently and in a variable and permanent way. For a distributed ledger, a blockchain is typically managed by peer-to-peer networks, collectively adhering to protocols of validating new blocks. Once the data in any of the given blocks cannot be altered, then then it is retracted. Okay. So this is the definition of blockchain, and we will be going through every line of this definition. So let's start. When we say a blockchain, okay, the first figure that comes into our head is there is a block, okay, and it is somehow chained. Okay, I'm trying to understand the whole concept by automation. Let me also first of all give you an understanding that blockchain is not Bitcoin. Blockchain is the technology on which Bitcoin operates. So it is like an internet on which an email is used as the transactional medium. Okay, in the same way, the blockchain is a technology, and Bitcoin is one of the offerings of the blockchain. Okay, so first of all, do not get confused about Bitcoin and blockchain. Now the first line of this definition says is, I have chosen this definition because this is the starting point of our talk. So let us understand it through the definition. It is a block and a chain. Okay, so fine, it's a block and a chain. Okay, and how are the blocks connected? Block are connected through chain. Okay, so each block should have some property, and the chain should have some property too. Okay, so we are looking into this. Okay, a block, okay, is encrypted. Okay, and a chain is encrypted. Okay, and what does the block contain? The block contains transactional information, timestamp, okay, and the user signature. Okay, so if we imagine it to be like a blockchain thing, wherein we can see in this diagram, okay, that there is a block. In that particular block, there is a transaction. Okay, there is and the transaction belongs to a particular owner, and then there's a hash table, and that hash table connects to the signature. What I'm trying to say over here is that if you have seen something like data connections or a disconnected array, this is a kind of a formation. In C#, you have or C++, you might have seen something which is called a data structure. Okay, where you created forwarding data and reversing data, the data structure. So this is a kind of data structure. Now, why is this structure so revolutionary that it has taken over with the financial institution by storm? Okay, now if you look at this particular structure, it has got transaction data, okay, owner's public key, okay, there's a key which is an encrypted key, and a hash table and the hashing number which which is a randomly generated number, and the owner's signature. We will see about this. Okay. So this is the structure of the block, and this is the structure of the chain. What is happening is that every time there's a transaction that is happening, the previous transaction is somehow changed. Okay, and we will look into the type of algorithms that it is using to change those transactions in a moment. But you can simply understand that whatever the transaction that is happening, okay, by a person, okay, these transactions are changed. Okay, and not only this, okay, whatever the transaction that is happening by the other person, okay, it is also to put into ledger. Okay, and this ledger is an open ledger, okay, which we call hyperledger. Okay. Now, what is why this particular concept is taking financial institution by storm? This concept is taking financial institution by storm because all the financial institutions work on the principle of centralized data, and here the data is not centralized. The data is spread, okay, to everybody, to every node. Now we will talk about node in a minute, but you can understand that if there are 5 computers, okay, then the data is distributed on all the 5 computers. Okay, so there is no one central place. Now, say for example, so if I want to make some changes into my data, and this change doesn't reflect on the 4 other computers, so we can easily identify that there has been some malpractice or some manipulation that has been done to this particular data. So it is, as it is an open ledger, so people are able to verify, validate. Okay. Now this gives a scenario wherein all the data is freely available. Okay. So everybody knows how much money Mr. A has in his pocket, or how much money Mr. B has got in his pocket, and so Mr. C has got in his pocket. Okay. No, it's not like this. It's not as simple as this. It's too simplified, but we will come to this particular point. Now, the other point over here in this particular arrangement of distributed ledger is that whatever transaction that one is making, okay, needs to be synced to all of it. Okay, now this is a challenging thing. This is this needs some attention, and we will give attention to this part as well. Okay, now let's see in reality, see in the sense of
I have a question regarding the previous slide. Can you go on the previous slide once? Yeah, so here you have mentioned owner zero signature. So where does this owner zero signature comes up, and how we authorize, or like how we trust that owner zero?
Okay, when we are going to see how the blockchain is working, okay, we would definitely look into this. Okay, this is just a kind of very introductory diagram. We will go deeper into it. Okay, and we are going there. Okay, just hold for 5-4 minutes. Okay, and you'll get your answer. I have
okay, sure.
I have noted down your answer. Okay.
Okay, sure.
So what is happening is when you transfer money. Money is meant for transfer. Okay, and when you transfer money from India to any other country, so how does it happen? It happens through a intermediary. Okay, what is that intermediary? That intermediary is bank. Okay, this is how the normal transaction happens. So how it happens is that you give the money to the bank and ask the bank to give it to some person in Africa. Okay, for example, if the bank takes a slice of your money, okay, and then searches the person in Africa, okay, and gives the money to him. Okay. Now what would happen if you can directly send the money without a intermediary? And this is the revolutionary concept of the blockchain. What it is doing is is as we have Mart, as we have Walmart, as we have Amazon, as we have other shopping systems, okay, where the intermediaries, okay, have been suppressed, have been killed. Okay, this is a concept. Okay, which actually kills the concept of the trusted intermediary, because the concept of the origin, or the motivation of blockchain is not to trust bank, because the bank for centuries have been doing malpractices, have been looting, have been doing a plunder to the customers, have been doing a lot of problem to the economy. There have been the reasons for the crisis in the economy, and we have that in our slide. If you go to the part where we have discussed the wrongdoings of the banks, you will find the hordes and tons of the instances where we have I have documented ever since 16th century, how the banks have been actually plundering people, okay, and have been the source of crisis, economic crisis in the country, in the world, and they have been the reason why there is so much of disparity between the rich and the poor, okay, and also all sort of things, because they have got so much of money and so much of autonomy and so much of power, but that they have been kind of manipulating with it and have been doing not so appreciable practices. Okay, and blockchain, okay, actually it takes the bank out. Okay, when it takes the bank out, okay, it is ready to create a very different type of economy. So we will discuss about that as well. Just give me a second. Just a minute. Give me a second. Hi guys, are you guys able to see the screen, and are you guys able to hear me okay? That's the question. Somebody from the audience had actually walked down to me and said that he is not able to see the screen. Is it right?
Screen is coming slowly and your voice is breaking a lot in between.
Okay, it's coming.
Yes, and at the moment we can see a black screen. We cannot see the slides. Are you sharing?
Yes. That is because he shared only the PowerPoint.
Yeah, so I shared PowerPoint. Okay. Do you want me to share the entire screen? I can do that. That's not a problem. This helps? Is it audible to everybody and visible to everybody?
No, it's still loading.
Audible but not visible yet.
Yeah, it's okay now.
Yeah,
so this is the organization internet. I wish I can do something about it. So what is the problem? Okay, one, it is taking a lot of time to send money to the right person. Okay, second, a slice of money that have been that goes from one person to the other. Okay, is right now in my imaginary diagram I have said $1. Maybe it is more. Okay, I don't know about it. Okay, so there is there is an country tariff that applies. Okay, I don't know how much it is. Okay, I'm not an expert in it, but there's a lot of money that that bank takes. Okay, to transfer money from one country to the other. Okay, a bank, not Western Union. Okay, even Western Union takes it. So the problem over here, the first problem over here is depends on third party. It is time consuming and it has cost. Okay, now we want to cut down on it. Okay, and this is why the blockchain was devised. Now how this is working, I told you it's an open ledger. Okay, where everybody is able to see everybody's ledger, but nobody would be able to recognize it. That's another point. Okay, because they are all encrypted. But they are able to see everybody's ledger. Okay, and thus be able to validate it. Now, if you think I am able to see your ledger, it's not the right way of thinking on it. The nodes would be able to see everybody's ledger. Okay, now this is a diagram that I'll just show it to you how this works. Okay, so A is transferring money to B. Okay, and then it gets recorded that in the ledger it gets recorded that A is sending money to B. It is success. Okay, and then B is sending money to C. Okay, and it is again a success. Okay, C is sending money to D. It is again a success. Okay, but now you see A wants to send $15 to D and it fails. Now when this is on the central location, this looks like this, but when it is on the blockchain, all the nodes would have an information of what is happening. So there cannot be a duplication of money. Okay, there cannot be check bouncing. Okay, so what normally happens is in the international transaction that I send money to somebody, and then from the same account I send the money to the other person. Okay, although I do not have the balance. Okay, and then there is a chaos. Okay, that happens, and a lot of things that happen. Okay, in the financial institution, in their managing of the records. This is not happening over here. Okay, as per my simplistic slide, because there is no duplication of transactions. Okay, but all these transactions are staying with the nodes, so all the nodes are able to validate it. Okay, and this gives rise to another problem, that is thinking of all ledger. Now this is the thing. Okay, you see, now one ledger is in US, the other ledger is in Africa, the other ledger is in Australia, and the other ledger is in India, for example. Okay, so how is the ledger being synchronized? How does it happen? Because the very first important concept of blockchain is open ledger. The second most important concept, because without this concept, the blockchain would have never ever been possible. Okay, that is mining. Okay, this gives rise to another problem of synchronizing on ledger. Okay, now what is mining? Miners are nodes. Okay, I'll read it out from here and I'll explain it to you. Okay, mining is a record-keeping service done through the use of computer processing power. The miners keep the blockchain consistent, complete, and unalterable by repeatedly verifying and collecting new broadcast transaction into new groups for transaction called blocks. Each block contains cryptographic hash of the previous block using SHA-256. Now, SHA-256 is the hashing algorithm. It is a encryption algorithm. Okay, which links the previous block and thus gives the blockchain its name. To accept the rest of the network, a new block must contain the so-called proof of work. The proof of work requires miners to find number of called nowens such that when the block content is hashed along with the nowens, the result is numerically smaller than the network difficult task. This proof is easy and any node in the network is verified, but extremely time consuming to generate as a secure cryptographic hash. miner must try many different Novus values. No, let's understand the role of miner. This is what Wikipedia explains about the miner. Now, understand it this way. Okay, I'm going back two slides back. Okay, 1, 2. Okay. Now, A wants to send money to B, or rather A wants to send money to C. Okay, it has shown its interest of sending money. Okay, now it has only said that I want to send money to B. Okay, so there would be miner in A, B, and C and D. Okay, they would compete among themselves. They would just compete among themselves to make that transaction happen. Okay, and how does the transaction happen? Okay, transaction happens. I mean, when A is sending money, okay, the money has not been sent. Okay, the transaction happens in two phases. All the transaction, even in the bank. Okay, one, it says that you want to send money to your mom who is in XYZ country. Okay, so she doesn't receive the money immediately. But the money gets deducted from your account immediately, and then the bank locates that particular person and then sends the money. So the same thing is happening. A wants to send the money to C. When it wants to send the money to C, all the nodes A, B, C, and D, they start to compete among themselves. Okay, to make the transaction happen. Now this transaction happens if you go back one slide back. Okay, you would see that you would see the transaction is happening based on a few of the algorithms, which is that, let me get the pen over here. Pen, pointer. So a transaction would have a transactional value, okay, encryption code, okay, and signature, okay, and then there is a hash code, okay, for this transaction. This hash code, there has to be connected to the previous transaction of this person, okay, so that it makes one full, so that it makes a complete block, one full block. Okay, so all this value, okay, all this value is a encrypted value. Now there each of the blocks or each of the nodes would compete among themselves to break that encryption. Okay, and each of these nodes would compete among themselves to break the encryption. Now, to break the encryption, they would have to do a lot of computation. They have to invest a lot of processor information. They have to go through. They have to do a lot of protocol mining, or they have to use some protocol which is called consensus protocol. So there are two things that are happening in the transaction. One is how much money you have right now. Okay, do you have the money to send or not? I have $100. I want to send $50. Yes, this transaction can happen. Now when I'm sending this money, okay, when I'm sending this money, it needs to be changed to my previous transaction. Okay, now, and to be changed to the other person's signature. So now these two things, okay, they are puzzling. Okay, and that is where the computation force is required. Okay, and who is providing this computation force? The nodes. Okay, there are nodes on every. There are nodes. Okay, nodes are or you can say miners. Okay, there are miners who are doing this particular job. Now, are these miners one person? They can be one person, but normally they are a pool of people, a pool of miners who actually ascribe themselves to be one set of miners, and then they they have a community, then the other have a community, and the other have a community, and then they all compete. What is the incentive of competing? The incentive of competing is money. Okay. The incentive of competing is money. Once a transaction is happening, and a slice of that money, okay, comes to the miner's pocket. Okay. And what is miner investing? Miners investing his processing capacity. Okay. So this brings us to a concept of something which is called distributed. This brings us to a concept of something which is called distributed computing. Voice is not clear. Is the voice not clear enough? Hey guys.
For us, it is clear.
It's clear.
Sometimes it breaks.
You can be a little slower while speaking so that if the voice is echoing, that would get clearer.
Yeah, because on the same floor it is fine.
Yeah, I'm shouting. Okay, so that's the on the same floor you can hear me fine. Okay, so now is there a question on this? Okay, how the miner is working and how the transaction is happening. To have a transaction, you need to check two things: whether I have got money or not. Okay, yes, I have the money. You have to link me to my previous transaction, and you have to link to the destination's to the destination as well. It is also encrypted. Okay, and these miners, they have the protocol to decrypt it. Okay, what are the protocols they are using? We will talk about it. Okay.
My question is still unanswered.
What is your question again?
Regarding the same slide which you were referring.
Okay, let's come here.
Yeah. So in this, the first transaction is saying owner zero's signature. So who is this owner zero, and why we will authorize or we will believe on this owner zero? Because this is a kind of certifying authority. The way the certificate works, a certificate have a public key and a private key. So that's get authenticated by the certifying authority, like VeriSign, Symantec. These are certifying authority, and Word knows them. However, in this case, the first transaction, who is this owner zero, and why we are going to authorize him, or why we are going to on that owner zero?
Fine, that's a valid question. Okay, let me answer this. Yes, over here, there is no Verizon. Okay, there is no certifying authority. The miners, show the proof of work. Okay, to the other miner. Okay, once the transaction is completed, the miner shows the proof of work that I have done the work. I have encrypted the puzzle. Okay, and then it gets broadcasted. Okay, to all the miners. Okay, and then they have to accept that particular transaction, and then hunt for the new transaction so that they can make money. Okay, so over here, this is how the certificate is broadcasted. Okay, now the public key. Okay, the public key is an encrypted key. In the same way, I mean, this is owner one. This is if it were not owner one. Okay, call the owner one as Ali. Okay, and call the owner one as what? Kumar. Okay. So
one is Ali, so owner one would be Ali, na?
No. The zero signature. The zero signature. It would be my signature. It would be my signature. There. So the owner of the key is Ali. Okay, and the signature is of Ali. Okay, and this transaction is to be made to Mr. Kumar. Okay, so then to make that signature happen, to make the transaction happen, my node needs to search for Mr. Kumar's node, and connect, and then Mr. Kumar's node verify my signature, and accept the money. Clear?
Yeah, sure.
Okay. And then when this is happening, okay, everybody in the network would know about it. Okay, I told you miners are competing among themselves. Okay, once they compete, okay, they show the proof of work. Okay, once they show the proof of work, everybody in the node had to accept that transaction, okay, as valid. Okay, and then they have to jump to do the new transaction. Now, in doing this, the transaction becomes faster, okay, and they are not being charged as much as bank charged them. Okay, and with the property of hashing, okay, nobody knows exactly is Mr. Ali. Okay, that is my alias, and who would know? No, and nobody would know who Mr. Kumar is. That is his alias. Okay, but transaction is happening. Okay, so there is a encryption and authorization and validation. Okay, these three things are working at random. So this brings me to the end of this particular topic of how this particular thing works. Okay, now if you have any more questions, okay, I would be pleased to answer it. Any question, anybody here?
Mohammed,
Yes, go ahead.
hello. So do you mean to say, like, for each transaction it's blocked then?
Each transaction?
Each transaction which we are showing, right? That's a block, correct? And when you say the first user one, which is having a public key, which is authorizing, and he's checking the authorization on this transaction to of user one. So I was a bit confused over there.
Okay, let me get the pen over here. I have a lot of things to talk. Okay, but I will take all questions. Okay, but something else. Okay. Over here, you can imagine it is an address of where it is right now. Okay. Here it is an address. Over here it is an address. Okay. You have data. Okay. If to make a transaction to B, so you would have to look for his address. You look for his address. Then you transfer the data to him. Okay. To be able to transfer the data to him. Okay. Do you would not like to validate whether he is the right user or not? Okay, and how would you validate whether he is the right user or not? So, you would run several mining protocols. Okay, several mining protocols, and mining protocols are consensual protocols. Okay, Byzantine resistant protocol. There are so many protocols. Okay. We will, it's very interesting, and if I have time, I will explain it to you in this particular session itself. Okay, so when he validates that this is the right person, okay, he sends the money to this person. Okay, any question? A transaction would have what timestamp? Timestamp, because it is, and then it would have a timestamp. Then it would have a signature, okay, of the person who is sending it, okay, and the transaction value, TS value, okay. So these are the three components that the block would have, okay, and the chain would have encryption values over here, okay. What is an encryption? What is the chain? Chain is nothing but a contract, okay. Contract. Okay, a very interesting question. That actually is very that actually helped me do a lot of search. Is that why is there a disparity between rich and poor countries? Okay, I also do coding. Somebody in US also do coding. Why is there? Why am I poor and why they are rich? For example, okay, it is the contract. Okay, the contract is an encryption contract. Okay, so the chain handles the contract. The transaction handles the data, transaction, string, and value. Is that clear? Any more questions?
Thank you.
Did it answer your question? Hello, hello.
Thank you.
Did it answer your question? Are you fine with the question answer?
Yes. Thank you.
Thank you. Okay. Now we are going to see what banks have the history of this particular thing. Okay. The history of the Bitcoin is knee deep into the problems that the banks have done to us. Okay. So let's talk about the cryptography. See, in 1977, Stuart Haber and W. Scott created a paper in cryptography. In 1992, Baers and Haber incorporated Meikle tree protocol. This is a very interesting kind of a tree in which I'll show you if I take it over here. Come on, open up. I have added the picture of this, but the picture of it is not so very clear. Okay. So it is basically there is a head, okay, and then there are so if I explain to you like this, there is a general and there are lieutenants, and under lieutenants there would be captains and there would be soldiers, okay, and then they would so keep on going, okay, and then this is how the encryption would happen. So it is happening at multi-layer, okay. These encryptions are very difficult to break, okay. So there is some encryption that we do in our coding, okay, which is there are two types of encryption that we do in our code in SQL, okay, in C#, okay. This is an encryption on multi-layer, okay. So one encryption has happened and it breaks that encryption into two trees, and then those two trees are being encrypted. So you can encrypt it, okay, but it is difficult to decrypt without a key. Okay, so that is the thing. That's the reason this encryption mechanism was taken into consideration. Now, Bitcoin, as I told you, it is the first distributed blockchain was incorporated as an anonymous person known as Satoshi Nakamoto. Okay, Satoshi Nakamoto. Okay, and he is not the real person. Satoshi Nakamoto is not the real person. It's alias. It could be a fake name, but this is the person. Okay, who actually put together all the information all the knowledge that were ahead of him, I mean not ahead of him, at the back of him, and created something which is called public ledger. And then he started something which is called Bitcoin. Okay. So there was this person, okay, created Bitcoin in the year, which was the year? Yes, 2008, I guess. Hang on a second. 2008, he created Bitcoin. That was exactly the year when there was a bank, crisis or depression. Okay, and because out of the funds sinking and the values going down, this particular thing came into existence. Now, one of the first supporter or adopter and contributor of Bitcoin, the receiver of Bitcoin transaction was Hal Penny, and these are very important questions. People do ask in general knowledge and interviews. Fanny downloaded Bitcoin, and how much Bitcoin did he get with his first transaction? He got 10 Bitcoins. Okay, for his first transaction. Okay, the early supporters were VDAI, created by Bitcoin, and then in the first year of the development of the Bitcoin mechanism, which is blockchain mechanism. Okay, and now you would be understanding there's just one Bitcoin. Okay, no, it is again a type. Okay, since blockchain is a technology, in the same way email is a type. So there can be Gmail, there can be Rediff, there can be whatever. Okay, so Bitcoin is a type. Okay, so earlier it was called Bitcoin. Okay, so in the first year he Bitcoined 1 billion Bitcoins. Before he disappears, this person, Gavin Addison, okay, became his hire here, and he actually did a lot of things in the Bitcoin. He created something which is called Bitcoin 2.0. So now this is the person. Does he look like any of you? He's also missing. Okay, anyway, small history of the Bitcoin. Okay, in 2014, the Bitcoin size was 20 gigabyte. Okay, and then it moved to 30 gigabyte, and in 2016 and 17 it moved to 100 gigabyte in size. This is the size of the ledger. Okay, don't misunderstand it in the description. Ledger means just data. So you can imagine how much data is being churned into this particular thing. Now this brings to a question that since you are using a disconnected computing, aren't you replicating the entire thing onto one node the multiple times while doing the transaction? Which means that if I'm doing one transaction, it will go to every country and in every city and in every mohalla and every house which is doing mining. The answer is yes. Okay, isn't it energy hungry? The answer is it was energy hungry. When we were using normal processors, but now we have started to use something which is called gaming processors, and now there are special processes for mining which are being used. Okay, which makes it more energy efficient. So there are reports that one transaction of Bitcoin takes away as much energy as Bangladesh uses in a day. Okay, so there are news about it. While researching, I saw these kind of news. Okay, so the counter to that is that that's not true. That were true. LG has sold so many TV, which is if you multiply the amount of TV that consumes electricity, and the number of units that it has sold, so it is equivalent to 2 times the electricity that is being used by United States every day. So which is not happening. These things cannot be measured like this. A lot of mining is done on iPhones, cell phones, iPads, laptops, and even in Raspberry Pi. So there are so many things which are, so many apps which are energy efficient. So this is rebuttal to that. Anyways, in 2009, Bitcoin network came into existence, and after Satoshi Nakamoto mined the first blockchain as Genesis block. He called it Genesis block. Okay, he embedded in the coin of this block was the time 3 Jan 2009, chancellor on the brink of the second bailout for banks. Okay, so if you go and study Bitcoin or blockchain, they have a lot of nemesis and for the banks. Okay, out of which this has come, and Now let's coming to the other areas where Bitcoin is being used right now. Now, so with 2.0, okay, with 2.0 Bitcoin, it is used as a programmable programming language that allows users to write more sophisticated and smart contract. I told you what a contract is. The chain is a contract. Okay. Intellectual right property. Intellectual right property. Now this is very important. Royalty of people are marked. Okay. So for example, I have created a cell phone or I have created a mask. Okay. The unit of mask that is being sold. Okay. I would not know if I want to get royalty. So if I put it into Bitcoin, so every time the mask is sold, okay, I would be the ledger would be intimated, and then my royalty can be charged accordingly. So a lot of royalty, music industry, intellectual property right people are actually coming up into this area and acquiring the 2.0 blockchain mechanism for their royalty. Now, interesting part of this is Bitcoin NXT is a very new experiment in the Bitcoin that was used by Russia with the help of IBM. They actually did a voting. They created a voting system out of blockchain mechanism. Okay. This is the end of the history. Any question on this? I would appreciate. Okay, so that we can start with the next thing. What the bank did to us. Okay, how much time do we have? We have 5 minutes. Any question? I can take those questions for a couple of minutes. Any question, anybody? Hello. Hello.
Yes, we can hear you. I don't hear any question.
Fine.
No, we don't have any questions.
Okay, fine. This is Meckel tree. Okay, this is a very wonderful hashing algorithm. Okay, let's go through this. The slide, you can use the slide as a note if you want, because I try to pack a lot of things in this book. Okay. So since the 18th century, you can see the list is endless. What are the depressions that have been created by banks? Okay, and these depressions, okay, are not the real economic depression. These depressions have been instigated by bank going cashless, bank going bankrupt, okay, and giving bad loans. These are the reasons for these depressions. Okay, more or less. Okay, don't take me by the exact words, but bank had a lot of role, okay, in getting our conditions worse. So this brings to the end of session as well. Now this is very important. Okay, this is the most wonderful thing that you can take home. Okay, and you'll like it. Okay, there is something which is called two general problem and Byzantine problem. Anybody have heard of it or not heard of it? Okay. So this when you do a let me get them when you do a disconnected computing or distributed computing. Okay, what does that mean? You are using everybody's processing capacity to get your work done. Okay. Even if you say, okay, I don't take everybody's processing capacity, I take the processing capacity of a pool. Okay, okay, pool can be called a community. Okay, so there are chances that some of the pools, okay, have low processing capacity. Okay, some of them have high processing capacity. Okay. Some of them could work as a traitor. Some of them could work as good guy. Okay. So what is the algorithm? Okay, how would you be able to actually secure your transaction, your activity in that particular scenario? Okay, so this brings to a question which is called Byzantine problem. Okay, and this is Byzantine problem. So here is the story, okay, which is to be thought of. Here is the fortress, okay, and here are the troops from different cities. Okay, they all want to go to attack and win this fort. Okay, the people are from Byzantine. Okay, so what algorithm, okay, would you use to communicate, because the communication between them is done through a courier. So there are no cell phones, so the communication is done through courier. Okay, what algorithm would you use that they all can attack the fort at the same time and win the fort? Okay, there are scenarios in which from this particular fort there can be this particular fort has sent its army, okay, which is in the guise of the attacker, but would slow down the attack or would stop the attack. Okay, could act as a traitor. So imagine all these people are computer nodes, and there can be few nodes which can act as a traitor. This is a serious problem of the distributed computing. Okay, so the question is in the scenario where blockchain is using distributed networking, okay, distributed computing, how secure is blockchain? You have to think about in which the transaction can be blocked. Okay, so there's no 100% solution to this. Okay, however, there have been a lot of research. Okay, a lot of white papers have been published, and I have gone through at least 10-15 of them myself. Okay, and the best of them is one that is able to predict against how many traitors we need how many good people. Okay, so says if 1/3 of the unit becomes traitor, so the transaction would not happen. For every 3 traitors, I'm giving you the scenarios. For every 3 traitors, so we require 47 good generals. Now this brings to a two general problem as well. Okay, if you want, we can do a kind of a session on Byzantine problem. This is a very, very difficult and the most challenging problem, a mathematical problem that is being faced right now with peer-to-peer networking. Okay, and there are scenarios of impossibilities. Okay, that is being discussed. So in what are the scenarios it becomes impossible? Okay, so we can have a talk on this. You would be enchanted with the possibilities of this. However, I don't have too much of time to go through the Byzantine problem. To keep you updated, there is one more problem on this particular line, which is a mathematical problem, which is called two general problem. Okay, you can also hunt for this. Okay, and these are some of the very, very important questions. Okay, that you would actually be asked in interviews, which are kind of not which the technical interviews. Which goes algorithm like Google or Microsoft or Amazon or companies like this. They put you into scenarios to solve these particular algorithmic problem and see what type of answers you can come up with. Okay. Is blockchain more secure than current banking system? Of course, it is more secure than current banking system. This is why uh, if I tell you give you an example, okay, what is more secure and more stable as a government, democracy or a dictatorship? Okay, definitely you'll say democracy, because what would happen is for every kind of virus to attack a democracy, say for example, a bad guy to attack democracy, okay, there it has to invent, okay, new type of algorithm. So for example, a community is kind of influenced by a particular thing, then the other community doesn't get influenced by that particular thing. Okay, but in dictatorship, or when there is the one straight commune, okay, you just have to invent one virus and then it would go and do all kind of a destruction. You can take over that particular thing very easily because there is a lot of uniformity. Okay, similarly, in the distributed network, all the nodes are kind of a different protocol to get the work done. So, and these protocols are called consensus protocols. Okay, there is just no one protocol. Okay, so attacking these systems, despite the fact that there can be traitors and all those things, okay, it becomes extremely difficult compared to the banking system, which doesn't have so much of disparity of protocols. This brings to the end of this session. Okay. Now, to go through this, there are two type of blockchain. Okay, one is called encrypted blockchain. The other is called non-encrypted blockchain. And the non-encrypted blockchain are also called alternative blockchain. Okay. These are the names of the unencrypted blockchain. Lazos is one of that, and then there is Ethereum. Ethereum is a very popular name these days for these blockchains. Now remember this, okay? If there is a database for the blockchain, it is not a blockchain. Okay. For a blockchain to be successful, there hasn't to be any database. It has to be replicated across. Okay. It has to be an open ledger, encrypted open ledger. So lot of banks are actually creeping into blockchain mechanism using their own blockchain system. Okay, but those banks would be considered as one node, so they cannot kind of conquer the entire blockchain because of the architecture that the blockchain offers. Okay, it is very difficult to kind of reinvent for 10,000 things that are going in a particular blockchain environment. Decent is other very famous thing. Now another is these are the list of blockchains which are encrypted. Okay. Dash is a very famous blockchain. Okay, you will get a lot of documentation for Dash. Now, about blockchain, how do you get how can you make a career out of blockchain? Okay, there are two possibilities. Two possibilities of career. One is as a blockchain developer. Okay, there is a blockchain miner. Okay, now if you want to go for a blockchain developer, then what is the language that you need to know? Okay, you need to know all the language or any of the language. It is agnostic to language. It has more to do with algorithm than to do with language. Has Microsoft come up with any of the blockchain algorithmic language, because it comes up with a lot of structures and libraries? Yes, Microsoft has come up with one of it, Ethereum. Okay, you can find Ethereum with Azure. Okay, and you can learn the blockchain. Okay. If you know C#, can you use Ethereum? Yes, you can use. If you know Java, you can use Ethereum. Yes, you can know. So you just have to add libraries to that. Now, saying what are the areas that blockchain is going to influence on. There would not be any area in the earth, okay, that blockchain would not be influencing. Okay, however, in the closest net of blockchain, it would influence decent asset, economic and social structure, governance, law, product, service, environment, sustainability. Okay, and in future, in the outer circle, you can see there are so many areas. Are we saying that blockchain is going to bring back the privacy that is lost on the internet? We are hopeful. Thank you. There are a lot of bibliographic materials and reference materials in this particular PowerPoint slide. People who are interested, okay, can go through it, okay, and go for the blast. Okay, if any question is there, please fire on to me. Okay, we'll answer that. Question, anybody?
You sharing the slides with us?
I have already shared the slides.
Yeah. You're sending it across the mail, through mail, right?
I have sent this. I have shared the slide on the email. Okay, if you want, I can share the slide again. Okay, on the site itself. How do I send it? Blockchain. Hang on a second. On OneDrive. Okay. However, I have sent it. So send it again. I send it on a PPT. Okay. Just a minute. Blockchain. Let me download it. I downloaded it as, and I'm sharing it as a PDF. Is it okay? Or do you want it in the PowerPoint? Guys, somebody asked me a question. Okay. Okay. Do you want it in PowerPoint or sharing it on PDF is fine? Question. Now here's a question that I want to ask you guys. Okay. Do you find these sessions useful? And do you know the relevance of these sessions? Why do we do the sessions? First of all, do you find it useful? Hello? Anybody there?
Yeah, I can only speak for me, but I find it useful.
Okay, great. How many of you are here from Zurich? Because this session was initially Zurich, I guess. The next session would be with drones. Okay. Zurich wants people to know about drones. So I'm interested in fighter planes and drones. So we'll discuss about drones in the next session. How drones work, what is the mechanism of their working, where it is, how they are used, what are the protocols that the drones use, all the technical aspect of it. Okay, we will not go to the military of killing them and using them against Al Qaeda or IS.